All right, so but we're starting. We're talking about what's going to be on the final. So we're going to start talking about coffee enemas. All right, so
We give one or do we get one?
neither.
Can I
So,
get one right before?
I'm only going to tell you a classroom appropriate version for this. So this is kind of where it started. My
Read in your own details.
huh? No, I'm not going to tell you about my direct involvement. This goes back to my dad actually.
Oh.
So one might say, if you know me, and you see how messed up I am, my parents probably aren't that right. Okay, so my dad's got issues, and anyways, so he takes I don't know 4 million supplements, and he's a retired dentist. And the funny thing is that doctors, have you ever heard the phrase "doctors are the worst patients"?
Mm-hmm.
They don't want to listen to anything other doctors have. So he's on all sorts of like Chinese medicine teas and homeopathic solutions to stuff. And anyways, years ago, I don't even remember what problem he was treating. he was treating some problem. Sam, you're here. What's kicking? Were you? Oh, I just stopped looking for you. It's a thing. I saw you playing in the music thing. Are your drums and stuff?
Yeah.
Yeah. So I was at the thing on Saturday. Yeah, that. Yeah, what were you even playing? Was it like because you couldn't see it where I was sitting. You just saw you and two other guys on either side just standing there, just kind of looking weird.
That's right.
Playing. Oh, so yeah, like a snare drum there. I gotcha. Couldn't decide if it was that or maybe a xylophone or something. Okay. So anyways, so I don't remember what my dad was treating, but one of his shamans or something turned him on to, or his witch doctor, I don't know which one, turned him on to phrasing, the idea of coffee enemas.
Caffeine coffee?
Actually, that did become a discussion. That was supposed to treat something. It was a detox type thing. And my dad never drank coffee historically. So all of a sudden they're like buying coffee in bulk and some of that. And, then he would have the internal joke like somebody would ask me what coffee. He says, I don't drink coffee, at least not orally and stuff like that. So I started calling my dad Sanka. Sanka coffee. So that was his nickname. And he'll still answer to that nickname. But that kind of started a tradition. I don't even tradition is the idea of coffee enemas became desensitized in the family, and then things happened. Man, I can't even take you seriously. So, okay, what are you dressed up for? What's the story?
Senior Summit presentation next hour.
Oh, really? What's your project on?
CS website.
Delivering the good word. I'm delivering the good news. All right. So, in any case, what was I talking about? Oh, homework assignment. So, homework assignment was for block expressions?
And sets.
Okay, so set expression. And what was set expression supposed to do? Allow us to update a variable in our environment, and then a block expression should boil down to, should allow you to have a collection of expressions that should get evaluated. Okay, so let's go ahead and give ourselves a test case for our set expression. So let's do, actually let's steal one of these. Let's just change the first one. That'll be good enough. Because the problem was that I was impractical, or while was impractical, right? So the idea here is that we should be able to say something like, let I equal 0, as long as I is less than 5. Maybe boil down to I, and then display and then update the value of I, right? So you might have a block expression in here. So block is going to be a list of expressions. Let me just close this off here. A block is going to be a list of expressions. And in this list of expressions, we might have the expression I, and then we might also have the expression set I to plus I1. Something like that. So our block expression here would say do this first, which should boil down to the current value of I, which is 0. Then do this expression, which should increase the value of I in the environment to 1 greater than it used to be. Make sense? So this is what we're supposed to get to work? Okay. So let's start off with our parse. And make sure that guy's producing what it needs to produce. So how was this assignment? Did it go all right? Was it bad? Really? I thought it was supposed to be easy. Was it bad? Did you get it working? Did you even try to get it working? Joel, you didn't get it working?
Did anybody? Because I didn't.
Not the way it's going.
Amish got it working. Amish was showing it. His supports.
He's like the mad scientist over here. This is his language. He's like living in the code.
You see that?
Now you know No Shave November is over.
That
No,
beard
he's
is
Amish.
because
They
he's
grow
in the
it all
code.
year.
Huh?
He's Amish. They grow it all year.
Yeah, did you even start growing that in November? I feel like
No, this was I just stopped shaving it when the semester started.
yeah.
It's a money saving thing. I ran out my last. Sam's like, I know what that's all about. My razor broke, and I'm not going out. I'm not going out and buying another one.
Why would I do that?
Well, he doesn't have a horse and buggy here, so.
This is true.
My horse threw a shoe.
Farrier can't get in.
So it was the block expression that was the tough one. Really, I thought this was going to be an easy assignment. Oh, this is going to be nice.
Weird.
Did you do it, Paxton?
Not correctly, but I did it. Not the way you would have expected.
Well, does it function?
Yeah.
Okay. Well, so how did you do it if it's not the way I expected?
Well, kind of cheated a little bit in the back end.
I mean, because on one hand you might say, well, can't I map a val expression across that? But you really can't because each line is related to the previous one. So you really have to go through it one at a time, right? To evaluate.
I just used recursion.
Yeah. But map seems like it would be the right thing, but it isn't the right thing. So how did you do it? I mean, it seems like there's only one way to do it in the context of our...
Pretty much, but the way I had set written, I didn't want to change set, so I had to change plot.
All right, so let's go. Let's get our parse working first. Where's parse? Parse expression right here. All right, so if we're looking at a Boolean, a number, otherwise if it's a symbol, we're going to ask, is it the symbol here? Let's do right in here. Let's steal this guy. All right, so this is for set. And set should be a, actually, hold on, let's think about this. Well, they can exist independently of each other. Let's just do this for now. So we'll say that's going to be a set expression. And then this guy is going to be, if it's block, we're going to have a block expression as a list. But then the How's this going to
You have
affect?
one extra parenthesis.
How is this going to affect the rest of it? So we're checking to see if it's a reserved word. Oh, and we need to add those to our reserved words, right? While set and block. All right, so for this particular guy, we should get a let expression that has its variable value pairs, and we should get a while expression that has this body, which is an app expression. Actually, that's an op expression, right? And that's for the bool expression. And the other part of it is going to be a block expression that contains these guys. But that's the part I'm not sure if we've done at this point. Let's run this. All right. So that's that. That's that. That's that. All right. That's what it should look like. Where are we getting the rest of the body of the block? All right, so if we go through the reserve words,
You don't though.
yeah. If it's a reserve word, which that should be, because we have our list of reserve words up there, then we're going to find out which reserve word it is. If it's that reserve word, do that. If it's that reserve word, do that. If it's that reserve word, do that. Do that. Do that. That should end that cond. Okay, that ends that cond. This ends that cond. All right, so we're only going to do that cond if we are in reserved word, if it is a reserved word. The else is going to assume it's a var expression if it's not a reserved word, right? We're looking at a symbol, but it's not one of our reserved words. We'll assume a var expression. If we're not looking at a symbol, we might be looking at a lambda. So this would be a list that contains a lambda and then do all of our other stuff. Okay, but this is still breaking. So somewhere in here, was it up here? Did I not close reserve word?
No, it's down. It's down in parts.
The end of part? Well, I didn't take anything off of there. That guy should end that cond. Should this also... No, that's the next dude there. Oh, this is for symbol. That ends symbol.
You have one extra on.
No, I think this is right. I didn't have the closing one for this symbol conditional, and now this should run.
Take the one off that you just had and put it up one.
Yeah. That's
Take
right.
this one off?
Yeah.
Go up one line and put it there.
Do it.
You put it there.
Oh, because we're finishing reserved word. That finishes reserved word. That finishes symbol. All right, perfect. Let's see what this guy actually looks like. So we have an app expression that contains a let expression that contains an app expression that has our environment. So we kind of implement all our stuff in terms of app expressions, right? So a while expression is an app expression, and the body of that while expression has an app expression containing, well, its first element is a Boolean expression. So this is list, that stuff. So that's the first element of Well, that's the second element of that app expression. First element is what kind of app expression. It's a while expression. Second element is our Boolean expression. So that's a Boolean arith op expression. Third element is the body of that while, which is an app expression containing a block expression, which contains an app expression. So that block expression contains several different expressions. The first expression in the block expression is the one that boils down to, let's see. So it's a block expression whose first element why is that guy? So the body of the block expression is being treated as an app expression. And that app expression functions as a list of expressions. So here's expression 1. And here's expression 2, which is our set expression. Okay, and the set expression takes, so that is, why is a block expression? Read. So block.
What are you wondering? Why it's parsed that way, or?
Yeah, and I think it's correctly parsed that way. I was just wondering why it got flagged as an app expression, but the other guy did not. So here's our block expression is an app expression because it's being applied to some other stuff. So this guy looks like an app expression, just like a while loop looks like an app expression. So the body of that block is an app expression containing the first expression is var xi. The second expression is an app expression where we're going to do a set expression, applying, setting that variable name equal to this value, right?
Which is also an app expression.
Yep. So this is parsing correctly.
Yeah.
All right. Or at least it's parsing in a way that could be correct, that we just need to write the code to support. All right. So let's do a set expression first. In order to test that, we'll have to give it an initial environment with a value in it that we want to update. Is that right? Yeah, and then we'll have to print out that environment. Okay, so let me, I'm going to steal this line here. And I want to just give myself a simple expression. So this one's going to be set I to be plus I1, like that. All right, so this guy should just be a app expression that is a set expression. So let's make sure we can handle set expressions first. All right, so, and what are we doing? We're going to update the environment with, and we're not going to check for errors. We'll assume that if we're updating the environment, the variable that we've requested to update is in the environment. Okay, so we're looking at a flavor of an app expression whose catter is set expression. And then what will we do? We'll take the CADDR, which is the var expression, and go and look him up in the environment, and then set it equal to eval expression of CADDR of that guy. Okay, doesn't seem like that should be too bad. All right, so here's our else. This is the eval expression, right? Okay. So there's our while, there's our let. Let's just throw this guy after the while. All right, and this is a set expression. All right, so if we're looking at a set expression, then what are we going to do? I think we already have an environment that supports this, don't we? We have a Oh, no, we need to search our environment. I thought we already had an environment that could update a value. When we first learned environments.
I thought that was what this entire thing was but they didn't do that.
Well, we don't. So we need to define update environment. Okay, update env is going to take in a var a val and an environment, and it's going to go through and it's going to find that var and update its value with this val, searching the most local scope first. All right, so and the ultimate output is going to be that we're going to be building a brand new environment. So as we need to look in the most local scope first. Then we need to search that guy. So apply env for the current value. So if that guy does not return a false, that means we're in the right place, correct? All right, so if we're in the right place, we need to modify that scope, ultimately returning an updated environment because we're going to have to change the value of that environment. Okay. So this is going to be a lambda. We're going to say if null env, we can go ahead and return, we'll do it as a cond. Null env should return a false because we're out of crap to check. And we're going to assume that that's never going to happen in our world. We're only going to call update if there's actually something to update, but this is our bailout. All right, so otherwise we want to look at the current scope in our environment. So we're going to go ahead and let current scope equal the car of env. Right, that'll be the current scope we're interested in. Okay, and then we're going to ask the question, if, let's see, apply scope on that scope. So if apply scope, passing it our variable and the current scope. So the variable is var. The current scope is current scope. If that guy returns something other than false, so if that guy is not EQ.
You gotta use EQV there, just so you know.
Oh, because that'll check for numbers.
Yeah.
So if that guy's not equivalent to false, then what will we do? Well, that means we know it, that we found the scope that has that dude. All right, so if we get inside this if, then we know that we need to update that scope. So let me just, here we'll call update scope, even though this is a nothingness right now. Just put that as a placeholder. The false, the else would be, we're going to go ahead and we're going to boil down to consing current scope onto update env, passing it var val and the cdr of env. like that. So just pass the buck. But if we're sitting right here, that means we found the scope that has the variable that we want to update, so we want to rebuild that scope. And a scope is a list of name value pairs. Is that correct? That's how our scopes are implemented. A list of name value pairs as lists. It's a list of lists where each list is a name value pair. You invented it. Is that what it looks?
Yeah.
All right, you guys did the homework. I haven't seen that in a while. All right, list of name value pairs. Oh my gosh, this is death. And this is the easy part of the assignment, right? And wait till you guys see the next homework.
Your definition of easy and ours is far different.
Well, this doesn't seem that bad, does it?
So far, no, this isn't. I didn't find set to
Yeah. So here, I'm actually gonna. We're gonna call update scope here. Actually, we're gonna do this. We're gonna say cons update whatever's returned by update scope, passing it var, val, and current scope onto the coder of env. And we'll write update scope to take in a var, a val, and a current scope that presumably has that var in it. And we'll rebuild that scope to have that current var list removed and put the new placeholder in its place. Okay. All right, so we'll do define update scope to be a lambda that takes in a var, a val, and a scope. And then what we'll do, let's see, can we do something awesome here? Got to be able to use math. Can we use map here? I think we can use map. It's just going to be a list of lists. Yeah. Oh, this is going to be epic. So we're going to map what function, the function that's lambda that takes in a list. Then if car of that list is equal, we can use EQ there, is equal to var, then we're going to boil down to list var val. Else just boil down to list. And we're going to map that across the scope and boil down to that. So for every element of that scope, each element should be a toList. We're going to pass that list into this. If the car of that list is the variable that we're interested in, we'll just replace that toList with our own version of that toList, which has the new var val pair. Otherwise, we'll just leave the list alone. So this should give us a brand new scope. Right? All right. So that should update env. That should update scope. Those have to be right. Are you spreading the good word?
It's not a Jehovah's Witness.
Huh?
He's not a Jehovah's Witness.
I thought Mormons are supposed to spread the good word too. Or is the good news for the...
Oh, I'm sure it's that too, but like, I guess the stereotype that maybe you're attributing to him is that of the Jehovah's Witness. Yeah.
Oh yeah, they do.
Oh, yeah.
Oh
Do
yeah.
they really?
Oh, yeah. They ride bicycles. No, they do. I'm not even making that up.
Like one
Is it one of those like two-person bicycles?
I don't think so, but huh?
Do they go in pairs?
I think pairs.
Yeah,
that makes sense
They're
to
like
entertain them.
required to, aren't they? For
Yes.
religion?
Yeah.
Yes.
There's a whole movie about that all of you should see.
Book of Mormon, yeah.
That's not the one I'm talking about. I'm not going to say it out loud. It's a little bit of an interesting... It's the makers of South Park made the one I'm talking about.
Yeah, the Book of
Yeah.
Mormon.
Oh, no, there's another one. Yeah. Starts with an O-R-G. Just no, it's one of the original. It's their first one. Or Orgasmo.
Oh, okay.
But it's worth it.
Yep, now your ads are really going to get interesting.
Yeah, he becomes he goes door to door as a Mormon, and then he gets cast in a adult film as a superhero. And he also happens to be a ninja. It's a pretty good movie.
Got a 6.2 out of 10.
Yeah, but what did Basketball get?
What did what get?
You never saw Basketball? Same guys. You saw Basketball, right?
No, we're all we all should be familiar with that. I mean, you've mentioned it multiple times.
Basketball Diaries.
No.
Basketball.
It's the South Park guys, and they invent a new sport that's a combination of baseball and basketball. It's called
It's
basketball.
got a 6.6 if that's what you were trying to ask.
6.6.
That's a good one too. You've seen basketball, haven't you? Who are you people?
We watched that for the final. I don't know. When I was 5 years old, I probably
review.
wasn't watching these kind of movies.
That movie came out when you were 5? Basketball?
Who's being dropped on his head?
I saw it when it came out.
98.
I was 8 years old. I was 8.
Gosh, I'm so old.
I know. 98.
I was 8.
I was already a professor. Hey, no wonder I'm getting gray hairs in my beard. You see them?
Just
Oh yeah.
Just in
Yeah,
your
a
beard?
little bit.
Well, I let it grow out. It gets worse.
Okay.
It's very
But
sad.
do you ever let it grow out longer than that?
Well, yeah. Whenever I get the stubble here, then that's the equivalent extra stubble here because I get lazy. But it's not because of I don't have a razor. So it's because I'm just lazy, but not as lazy as these guys. Well, Sam is just being practical. Amish is being lazy.
I have a razor.
Those are two.
Well, I think it's a little late to use a razor at this point.
You gotta use.
You gotta borrow those sheep shears.
Yeah.
So I think if you guys are looking for a Christmas present for Sam, we know what he could use. I mean, and with that, you're going to probably want to get an initial matches to burn it, do the initial burn off. Right?
You gotta burn it off. So you're not
Yeah, although it doesn't look bad on you.
Well, his beard is more even.
Yeah, see, it doesn't look bad on you. I mean, this is more Unabombery. Yeah, you know, if you
Didn't somebody say that you look like him?
yeah, if you walk into the 7-Eleven, you see him over in the corner twitching with a Slurpee, you walk out.
You use that little Swift app that you're writing for your watch.
Use the distress app. It's like, I'm at the 7-Eleven. Slurpee guy's back. All right. What was I doing?
No idea.
Basketball.
Orgasmo, Mormons.
Eval expression. Where's my eval expression?
We're good.
Set expression right here. So if it's equal to a set expression, what do we want to do? We want to go ahead and set expression is just going to have two pieces of information, right? Let's look at our set here. So the CA, where's my set expression come from? The CDD
No, you're taking the list ref from.
okay, yeah. So that's going to get me this part. Then what I want to do is I want to call update environment.
On everything else.
So this guy's ultimately going to give me a new environment. That's what his output's going to be, right? So we want to call update environment on the eval expression of this guy, as well as the eval expression on this guy. Okay, that's it. Okay, so list ref. So list ref. So we're going to call update env. Passing it, the val will be eval. Is it exp or expr? Exp. What expression are we evaluating? We're evaluating this expression right here, which should be list ref LCE2, right? List ref LCE1 is this guy. LCE2 is this guy. Sound accurate? Wait, I'm lost again. Where's my
Right there.
val expression on that guy too, given the current environment, along with eval. Let me just steal this line.
Do you want the var exp to be passed into that?
Well, yeah.
Oh yeah, you're.
I mean, I need to evaluate that expression in the current environment in order to update the value. It's going to be 3. So set expression is going to say update the environment. What environment? Oh, I need to pass this guy the updated environment as well. Or the environment I'm updating, which is env. So update env with what? This variable name, which will be the result of evaluating the expression this guy, bucket 2.
Wouldn't that give you the value it boils down to, not the?
Oh, I think you're right. You are right. A val expression, var expression will boil down to its value.
So you just want the.
I do want to evaluate this guy. The first guy, I want to extract the variable name. You're right. All right, so I'm not evaluating that expression. Instead, what I'm doing is I'm saying, give me list ref 2 bucket 1.
Oh, good, it's not just list ref two. Is it?
No, it's list ref.
Oh.
Um,
Hey, I think the first. No, you're the second.
that guy, bucket 1. That will be, so that's going to say, give me this dude and give me bucket 1 of that dude, which should give me the I, right?
Oh, yeah.
Yep. This will be the,
Okay.
that guy right there boils down to this list right here. And then list ref at bucket 1 of that list will give me bucket 1 here, which is the I. Okay? And then I want to evaluate the second expression. So that should be set expression. All right. And then I should see, in order to test this, if I'm going to run this program, I need to give it an initial environment that has an I in it. So what is that? Extend env takes in a, I guess we could just fake it. All right, so an environment is a, oh no, we really can't. Extend env,
Put an I and then
empty env, and extend env takes in a,
list of variable value.
takes in a scope.
Do you don't we have the extend env for let that you can just steal? Like that would do it.
Here's extend scope. So I need to do the empty scope.
Well, scroll down a little bit.
On,
Steal the.
no, we're fine.
Well, wouldn't it be?
We'll take the empty scope, we'll extend that with the var val, and then we'll extend env with that. Yeah, this is easy. It's gonna look like train wreck, but it's going to be easy. So we'll extend scope. What scope? The empty scope with I0. So that's going to give us a new scope. And then we're going to extend ENV with that scope and the empty ENV. We're going to get an error?
Yeah, you don't pass run program. Yeah,
You don't pass run program.
that's the environment.
Yeah, run program takes takes the initial environment.
That's fine.
We've always passed it. We've always passed it empty ENV. That's what it's always taken before.
Oh, it's done it programmed it automatically. Like there. Scroll up just a little bit. It's right there. Run program takes in an LCE.
Oh.
So we could
No, I get it. It starts that. So what we really want to do is we just want to call eval expression. That'll bypass it, right? We'll just call eval expression directly, passing it our lambda, and then passing it our expression, and then the updated environment. So this should give us an environment. Here, just real quick, I want to take. I'm going to print out this environment first, just so we can see what that looks like. And then we'll boil down to the new environment, which should have I is equal to, what is that, 1? Yeah, I should be 1 when it's done. And that's on which thing?
Scroll down. Scroll down.
No, I saw where it was, so that must be related to this guy here, though.
oh. No, you go down to your set. You have one too many, right? Or no. What's below the set? Below the set, you copy down underneath the comment.
Oh, that's my eval while. That's it's the what I copied before. Yeah, I actually put my implementation above where I wanted to say this. So I actually want that line to be there. Expect no. Oh, this should be an else. There you go. So if it's equal, see, I think in my mind I set it as an if, not as a cond. So if the environment is empty, return false. Otherwise, do all the stuff we did before. Okay, the variable is not defined. Oh, the quote guy. Oh, it was the same thing. I just had copied it. It works. All right, so there's our initial environment, and then there's the updated environment. All right, so now we have a working set. Now we can really test that in the context of a block, right? Okay, so let's go back to our block then. It's going to be this dude. And we can actually call run program again, given parse exp and expression. We can get rid of that guy. Okay, So now this is going to be in terms of our block expression. So now we need to learn how to deal with a block expression inside of eval expression. So we just dealt with set expression. So I'm just going to steal that part right there so I don't screw up again. So now I'm looking at a block expression. First element is a block. Okay. And what do I do if the first element is a block? Let's see, for right now, let me just do that for this moment. I want to go ahead and just parse it again, just so we can see what the parsed version of this looks like. Let me just cut this out real quick. Put it back in there. All right. Good enough. So if I am looking at a block expression, so specifically this part, the let portion of this should already work, right? This guy up here, this should generate our initial environment. We've tested that. We've tested our while loop on the impractical infinite loop, or doesn't it happen even once loop. So that part should work with the Boolean expression. But now we need to know what happens if we're dealing with an app expression that is a block expression. All right, if that's the case, then what we're going to do is we want to create a list of output for this guy. So in that list of outputs, we're going to go through and we're going to so list, this is list 0, list ref 0, this is list ref 1. So I want to get list ref 2 and I want to get the cooter of list ref 2. Right? The cooter of list ref 2 will be the list of my expressions. Agree with that? So if I'm in here, where's my I'm lost again. I'm always lost. All right, so is that how you guys feel? So we're going to call this list of expressions is equal to that guy. This is 0, this is 1, this is 2. So bucket 2 of that, and I want to get the cooter of that guy. That should give me everything but that app expression as a list of expressions. Right? Okay. And then let's go ahead and call it should be good. That's that, that's that, that's the end of that. So let's call eval block expression on that list of expressions.
You're gonna need to pass the environment too.
Yep. Within the current environment. Okay, that's good there. So now we need to go write eval block expression. I don't know why I copied it if I was just going to type it. So I'm trying to consider. The block expression seems like it's going to be easier The set expression seemed like it was the hard part. Was the problem is you couldn't get to the block expression? Because I thought everybody was saying the block expression was the hard part. And it wasn't that set expression was that hard, we just had to change a lot of things. I don't know, maybe I'm going to stumble onto something that I'm not thinking about here. So block expression is going to be a lambda that's going to take in a list of expressions as well as the environment in which they should be implemented. And what am I going to do is I'm going to say if null list of expressions, return the empty list. This is like one of our old patterns, right? Else cons eval exp on the car of list of expressions in the current environment onto eval block expression on the cdr of here, let's kick this down a line. List of expressions given the current environment. I think that should be it. And that should give us a, so this guy's going to take in a list of expressions. So in this guy, it's going to take in a var expression. I'm sorry, where are we at here? Yeah, it's going to take in our var expression I, so that should just boil down to 0 in this case. Then it's going to take in a set expression, which brings it to 1 greater than it used to be, updating, which we just tested before. And that guy's not going to have any outputs because what he's going to do, is that right?
So what you have to do though is that you need this to essentially boil down to an environment so that you can use it in your while loop. Because right now you're just getting
Yeah,
use of
the first element will be the 0. The second element is going to be our environment. So if we evaluate it to an environment, I see why this is difficult now. If I run this right now, it should give me my very first pass through the loop as well as the environment. But I never actually send that environment back to the guy who's executing the while loop.
you're just getting some values, essentially.
Okay, well, so let's.
You would, at the end of the day, you have to, instead of the empty set, I think you want to pass the environment.
It should
Is that right?
it should boil back down though, shouldn't it? 'Cause it's in the wild.
In our example here, what we're going to get is a list containing a 0 and then containing a new environment. That's what's going to be in our list. That new environment never gets sent into the while loop that was working with it. So we're going to have to update how while loops work, which is okay. So let's test to see if this guy works. The problem is that the while loop has a reliance on our block expression. So block expression in and of itself isn't a problem. It's the current way we have while loop implemented doesn't know about the existence of block expressions. They can't take that into consideration. All right. Because at the end of a while loop, the environment. Ooh, wait a minute. Let's think about that. As a block expression,
When a block expression gets evaluated, it should update the environment.
you should update the environment. You're right. So that means that when we eval this expression, we need to look at what that expression evaluates to. Is it a value or is it an environment? If it's an environment, then our next call to eval block expression should be that updated environment, not the old one. All right. So rather than consing directly, we're going to have a let expression here. So we're going to say let result equal eval expression on the car list of expressions given the current environment, except I have the E and V in the wrong place there. Car of list of expressions in the current environment. All right, so result will equal the result of evaluating that expression. That result will either be an environment or it'll be something else. If it's an environment, then I want to use that environment to evaluate the next expression. So how do I ask if something is an environment? How do I identify an environment?
Well, you can have the empty. So instead of having the empty environment be the empty set, you can have the end essentially just is a word. I don't know.
Like, hi, I'm an environment.
Something like that. At the
But then you
end- at the
reverse
very-
it. You
the
reverse
very
it, then
end
car
of the environment,
it.
It just says something like,
Hi, I'm an environment, and reverse it, car it. No, there's got to be a better way of doing that.
or you could just say that they always have to boil down to an environment.
Well, actually, doesn't every environment contain the list empty E and V somewhere at the end?
Yeah.
So if I reverse it and then car it, won't it be the list empty E and V?
Yeah, but it's a no, because you can create an environment that's not empty. So if you create an environment that's the list one.
It would still be on top. We have to use we can assume we're using our constructors to build the environment, though, and our constructors.
Every empty ENV does have an empty list in it at some point, right? Should have an empty list in it at some point, but is it not?
What is there?
Oh yeah, see, if I call the empty E and V constructor, it gives me this type of thing. So really, what I can do. Is we add a brand new scope to that. We could do something right here. Well, just for the sake of time for a second, I want to test something. Just so we leave this in a decent place. Where's eval? This guy right here. I'm going to bounce him back to what we had before. Okay, which should work for things that don't rely on environments changing. So let's test that guy and just make sure he does what I expect him to do. So it's not going to work on this dude. So it's not going to work on a while loop for right now. Instead, what we can do is we'll create a block. Actually, no, let's create a let. So we'll do a let A1, B2, C3, like that. And the body of that block will be block A, B, C. That should give us 1, 2, 3. We're going to run that program. That's the problem. Yeah, see, I think the issue is.
Oh, you're not passing it as an expression?
Yeah, I think that the parse is not doing. I must not have written my expression the way I think I should have written the expression. All right, so we have a let expression that's creating A is 1, B is 2, C is 3, so that part looks legit. Then we're executing this app expression that's a block expression, and that guy has a list of expressions. Is it assuming a list of expressions? How do I handle? Because I think, don't I burn past block expression?
Not in the parse.
No, I mean, the parse shouldn't matter if the rest of it is done the way it's supposed to be done. Okay, so our list of expressions is the LCE2. So this is LCE0, LCE1, this is LCE2. Okay, so I wrote my block expression wrong. These guys should be in a list. There we go. That's what it should look like. There's our list 1, 2, 3. All right, so our block expression currently works as long as every element in the list is unreliant on a changing environment. So then, having said that, how can we tell if something is a... Does anything else in our language right now boil down to a list? No. Well, other than environments, do any of our other? Because the question we need to ask is this guy an environment?
I feel like
A Boolean.
When you're opening it up to an empty list, though, like you just leave that possibility.
Well, at least for right now, I'm just saying. So if our current environment, a bool will boil down to a Boolean value, a lit will be that, a var will boil down to a single value, a lambda will boil down to one of those values. Everything will be a bool, a lit, or a var. So is it fair to say that, so let's see if this is the case then. Eval block expression. Do let result equal eval exp car list of expressions in the current environment. Then we'll ask if list
I still think he's making empty.
if result is a list, then let's boil down to environment. Well, just the string env. Actually, we want to let's cons the string env onto eval block expression of cdr list of expressions in the current environment. Otherwise, cons result onto, I'll just grab the rest of this. So if it is a list, I think the result being a list tells us it's an environment in our current language. So if the result is a list, it must be an environment. Therefore, for right now, we're just going to prove that we recognized it correctly as an environment and return, just have it return the word env. Oh, actually, no, we don't even need to do that. We don't even need to do that. We can do this. We know it's an environment, so let's execute the next dude in that new environment. Otherwise, cons the result, which must be something other than an environment, onto evaluate the block expression for the rest of it in the old environment. So for right now, we should get the same result as we had before. List of expressions. Yeah, because none of them relied on, none of them boiled down to another environment. But if I do set B plus B1,
What if you set A to a list?
we don't support lists in our languages right now. Yeah. I mean, I get it. Yeah. So hold on a second. So let's say A is 1, B is 2, C is 3. Then in our block, we're going to boil onto A, which is 1. Then we're going to set, then let's actually boil down to B, the original B. Then we'll set B to 1 plus B, and then we'll boil down to B again. And then we'll also boil down to C.
Does that block the first two need?
Wait, is that
Okay.
set?
You need to close the
Yeah, you can pull.
Thank you. So I have one too many here. So my block is going to say boil onto A, boil down to B, set B here, which should be an environment, and then we should evaluate this B in that new environment, which should now be 3, and then we should get 3.
And so she should only have 4 things in our list.
1, 2, 3, 3. Yep. So that works. All right. So what we'll do next time is let's now plug this into our while loop. I won't give you a homework assignment.
We're going over the final next class.
Yeah, we'll go over the final exam next class too. If you want, bring your, let's do this. I won't grade the homework you submitted today until after next class. So if you want to resubmit that with some changes so it's worth more points, I'll grade it then. So between now and next class, if you want to put a little more work into the homework that was due today, which effectively will be the solution we just did here, it doesn't quite plug into the while loop yet, but it works as a standalone block expression. Go ahead and do that just so you're familiar with it.
So essentially, block can have to boil